Hey everyone, welcome back to the channel. This is Innovation. Imagine a remote secured camera installation that needs to stream 4K video in real time to a central control room over several kilometers away, let's say 5 kilometers. The remote civilian side is off-grid, meaning there is no access to main power. It can only rely on the solar power system, typically providing 24 volts DC from the batteries. Despite these challenges, the control center requires a stable, high-quality 4K video feed with extremely low latency for live monitoring and a quick response. This scenario poses a tough engineering problem. How do we power 4K IP camera by solar energy and transmit its data over 5 kilometers with a minimum delay and no quality loss? Deploying the 4K surveillance system in this scenario involves several key challenges. The remote camera side has no AC grid power. We must power the camera using solar panels and battery storage, which provide a DC voltage, typically either 12 volts or 24 volt system. Any solution must operate within the limited DC power budget and the natural voltage fluctuation around the chosen system voltage. The standard Ethernet and the power over Ethernet cabling have a distance limit of 100 meters before the signal degrades. Even with the PO extenders or repeaters, reaching 5 kilometers is impractical. It would require dozens of the hopes and still be unreliable. Copper Ethernet simply cannot cover 5 kilometers, and this means a different transmission medium is needed for data. And 4K video streaming demand high throughput. The link between camera and control center must support gigabit-level bandwidth to comfortably carry one or multiple 4K streams without bottleneck. For real-time surveillance, especially if operators might control PTZ function or need instant situational awareness, minimum latency is critical. Technologies that introduces significant delay won't be suitable. A wired fiber optic connection is preferred, meaning low latency also means avoiding too many intermediate devices, so a direct point-to-point link is desirable. The equipment at the remote side will likely face harsh environment conditions, extremely heat, cold, dust, surges. It needs to be industrial grade and able to operate 24/7 with a minimum maintenance. Also, because the site is remote, the situation should be highly reliable with redundancy where possible. Any failure would be hard to service quickly. To overcome the above challenges, we need a solution with the following capabilities. Solar-powered PoE output. A way to cover 12 volts, 24 volts DC from the solar battery into a standard 48 volts PoE to power the 4K IP camera. This likely means a DC-to-DC PoE injector or PoE switch that supports wide-range DC input, boosted to the PoE voltage. Long distance and data link. Fiber optic communication link to carry data between the remote camera side and the control center. Fiber is required to bridge kilometers of distance, far beyond copper limits. The solution should provide an interface for fiber to easily connect the fiber optic cable. The fiber link should support gigabit bandwidth to handle the 4K video stream with single-mode fiber and appropriate optics. Distance of 5 kilometers are easily handled. The system should introduce virtually no additional latency beyond the inherent speed of the light delay. A point-to-point fiber link with no repeaters ensures latency is only a few microseconds per kilometers. The network equipment should toward the traffic at line rates with no significant buffering. Gigabit throughput capability is needed to ensure the 4K video frames are delivered in real time without dropping the compression further. The device at the remote side should be industrial grade, handling wide temperature ranges, electronic noise, or surges. Fanless solid-state design is a plus for reliability in dust or extreme climates. Essentially, it must be built for remote or harsh environments. Introducing the Innovation Industrial Solar PoE Switch Model 0504 GDF. This device is purpose-built for remote and solar power networking applications. In essence, this is a compact industrial PoE switch that accepts a wide range DC input voltage and provides PoE outputs, along with a fiber optic network interface for long-distance transmission. Alright, let's talk about some key features and characteristics of this device. First and foremost, this switch can be powered from 9 volts all the way up to 57 volts DC input, and covering 12 volts and 24 volts solar battery system comfortably. It has a built-in DC to DC booster that steps the low voltage up to the standard PoE voltage. In other words, even if you only have a 12 volts or 24 volts supply, the switch will inherently convert it to the 48 PoE outputs and properly power connect devices. And this makes it ideal for solar powered setup where only battery voltage is available. This device provides 4 RJ45 PoE ports that are fully compliant with IEEE 2.3 AFAT standards. And this means each port can deliver up to 30 watts to the PoE device, which is enough for most 4K secured cameras. The total PoE power budget is up to 120 watts when fed with 24 volts to 48 volts DC, or 60 watts when fed with 12 volts DC. Critically, the 0504 GDF includes 1000 base SFP slot as uplink port. This slot accepts a fiber SFP transceiver to connect the fiber optic cable. Using fiber, the data from the camera can be sent over very long distance. Multi-kilometers runs are supported. In fact, fiber link can be extended dozens of the kilometers depending on the optics. This easily covers the 5 kilometers required in our scenario, with plenty of headroom. By contrast, copper Ethernet is limited to 100 meters, highlighting why SFP feature is essential here. The fiber uplink ensures the high-speed gigabit throughput and low latency, directly from the remote side to the control center. Both the RJ45 ports and the SFP ports are gigabit capable. The switch's internal capacity is non-blocking 1 gigabit on each port. This means the 4K video feed, even multiple feeds, can be carried without congestion. The Linovation 0504 GDF is a beautiful harsh condition. It has an IP40 rated metal enclosure and supports a wide operating temperature range from -40 Fahrenheit up to 176 Fahrenheit, suitable for outdoor or unheated enclosure. Uniquely, this switch supports dual DC power inputs. If 2 separate DC sources are provided, the switch can automatically fail over to the second source if the first fails. Let's work through the connection layout step by step. At the remote side, the solar panel charges 12 volts or 24 volts battery with a charge controller. The Linovation 0504 GDF industrial PoE switch connects directly to the battery. eliminating the need for the inverter. The switch boosts the voltage internally to supply standard 48 volts PoE, and a single outdoor rated Cat6 cable links the 4K IP camera to one of the PoE ports, delivering both power up to 30 watts and data. And this setup supports fixed or PTZ cameras within 100 meters. A single-mode gigabit SFP module in the switch's SFP slot connect to the 5 kilometers of the single-mode fiber. And the fiber provides interference-free, ultra-low latency transmission, about 25 microseconds over the distance, ensuring smooth 4K video and instant PTZ control. At the other end, the fiber connects to the switch with an SFP port or a media converter, feeding gigabit Ethernet into the NVR monitoring workstation for real-time viewing. With 4 PoE ports and 120 gigabits budget, the 0504 GDF can power multiple cameras, wireless APs, or sensors, all sharing the same fiber uplink.